Okay, we have two more graphs here. So the next one's an absolute value. Absolute value, that's a V shape. Okay. The horizontal shift, that's whatever's next to the x, opposite what you think, so that's a positive 6. The vertical shift is after the function, which in this case is 4. You put those two values together, 6 comma 4, and your compress and stretch is whatever number is multiplied out in front, which this happens to be a negative 3. Let's go back and look at our basic shape. So normally from my vertex I would go right 1 and up 1, and left 1 and up 1. But I have a change. Because I have a stretch or compress, the vertical distance that I'm going, so instead of going up 1, I'm actually going to be going down 3. So my vertex happens to be positive 6, positive 4. Okay. So instead of going right 1 and up 1, which I normally would have, I'm going to go right 1 and down 1, 2, 3. Instead of going left 1 and up 1, I'm going to go left 1 and down 1, 2, 3. And there I can graph my absolute value. Notice it's pointing down because it's negative, and it's skinnier than it normally would have been because that's stretched. The next one is a square root function, which looks like kind of like a parabola on its side with its arm cut off, just one branch of it. The horizontal shift happens to be a positive 1. That's whatever's with the x but opposite. Whenever you have an x and a letter next to x and a number next to each other, you know you're taking the opposite. So my vertical shift, that's a 5. I'm going to put those together, 1 comma 5, and that is my vertex, 1 comma 5. My stretch and compress is whatever number's out in front. In this case, it's a negative or a negative 1. Going back to my basic shape, I would highly suggest you put that little triangle there and go right 1 and up 1 and label that. Normally you would go right 1 and up 1, but in this case, up 1 changes to negative 1, which is down 1. So I'm going to go right 1 and down 1. Now, when I'm drawing my square root function, make sure that you're starting at the vertex, which I drew in red this time, and continuing through the green. Okay, so that is your square root function with its transformations. Number 19, we're going back to inverses. It has a picture and it just says sketch the inverse. So I have an inverse f and I have a function f and I have an inverse f of x. So if I'm looking at the t-chart and I'm pulling these values off, the original function has points at negative 3, no, take that back, negative 2 comma negative 3. Let's see, it's got a point right here which is negative 1 comma negative 1. And then at 0 comma 1 and then 1 comma 3. To get from f to the inverse, all I'm going to do is use the definition of what an inverse is and interchange the x and y's. So instead of negative 2 comma negative 3, for the x value I'm going to write negative 3, and for the y value I'm going to write negative 2. The x and the y switch places. Notice I didn't mess with their negative signs. If it was negative, it stayed negative. If it's going to be positive, it stays positive. It just switches places. So at 1 comma 1, if I interchange that, it becomes negative 1 comma negative 1. Notice I didn't change the signs there at all. I just changed their locations, which happens to be the same. 0 comma positive 1 is positive 1 comma 0, and 1 comma 3 turns into 3 comma 1. All I have to do now to graph the inverse is just plot these points. Negative 3 comma negative 2. Negative 1 happens to be the same. 1, 0, and then 3, 1. And that is my graph. That's all I have to do on that problem. Now, as a checker, if you want to fold along this line, which is the line of y equals x, around the diagonal, the blue and the black should line up, okay? You don't have to. In fact, I'm going to go ahead and erase that red line. I don't want to confuse anyone later. But if you fold it along there, it should be symmetric along that diagonal. For number 20, it says, given the function, find the inverse. Okay, this is different than when we did earlier, number, I think, 13. If you look back on number 13, it says, gives you two functions, and it says, prove that they're inverses. On number 20, I just give you one function and say, find the inverse. This is different than number 13. You can't try to do them the same, okay? Just be careful there. So the first step on this problem, I'm going to write out the steps and the work is to take f of x and change it to y. So I'm going to do the problem y equals x minus 1 cubed. That's the first step. And it's easier when you have x's and y's because step 2 says take every x and interchange it with a y. So anytime you see an x, you're going to plug in a y. Every time you see a y, you plug in an x. That truly is the inverse of the red function, but it doesn't look real pretty. So third step is to solve for y so it makes it look a little prettier. So to solve for y, I need to get rid of this cube first, so I'm going to cube root both sides. The cube and the cube root undo each other, and you're just left with y minus 1. And now that the y minus 1 is kind of released from its cube parentheses, now I can add 1 to both sides and get y is equal to the cube root of x plus 1. Make sure that the cube root of x stops right after the x and the plus 1 is after it. The plus 1 can't go up underneath the radical unless you added 1 first, which in this case you wouldn't. Okay. Now the last and final step here is to take y and change it back into f. But in this case it can't be regular f, it's got to be the inverse. So we're going to write f inverse of x, and that's how you pronounce it, f inverse, is equal to the cube root of x, make sure that stops there, plus 1. The last one on this page, we said find the distance. So you have to know the formula for the distance, which in this case, x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of all of that. The hardest part of this problem is just being careful and plugging everything in correctly and maybe knowing the formula. So we have x2. Who is my x2? In this case, negative 1 minus, because there's a minus in the formula, x1, which is 5. Quantity squared plus parentheses y2. y2 is 3 minus, because there's a minus in the formula, and then y1, which is negative 2. So the minus comes from the minus in the formula, the negative comes from the 2. Now I'm going to work the inside, so I have negative 6 squared and minus a negative. Add a line, change the sign, that's really 3 plus 2, which is really 5. So we have the distance is equal to the square root of negative 6 squared. Negative 6 times negative 6 is positive 36, plus 5 squared, which is 25. I'm going to add those two together, and I'm getting 61. So the distance between those two values is the square root of 61 units. Now, I don't know what the square root of 61, it doesn't break down. I mean, if it could, I would have, but it doesn't break down with any perfect squares in there, so we are done with that problem.